Okay, boys and girls, take out your topical past year questions. Okay, can you go to question number 17? I'm not sure we did it before, but it's okay lah. If we did it before, if right now you can answer, that means that you understand the concept. Okay, can you go to this question number 17? Okay, so boys and girls, you try to solve it and then tell me your answer and then type your answer in the chat box. That I will explain, okay? So try with this question number 17. So we will have a cell, non-cell, okay? The non-cell is 2 volt. Negligible internal resistance, so we ignore the internal resistance. The wire is uniform resistant wire. That means that no matter the cross-sectional area is uniform. Okay, the wire is 10 ohm, length is 1.0 m. Okay, Z is a connection that may be made at any position. Okay, the slider can be moved lah. Move to the left, move to the right. Galvanometer is connected between Z and point Q. A new source EMF, okay, is roughly 8 milliwatt. 8 milliwatt. Okay, milliwatt is very small, very small. It's connected between the point P and Q. The EMF of the new source is determined. Okay, let's say we want to determine this 8 milliwatt. Okay, we want to determine this 8 milliwatt. We have to adjust the position of jack until the reading on the galvanometer is 0. So when galvanometer is 0, meaning that no current. Why no current? Because the potential difference across the point is the same. For example, I label this is X, here is Y. X to Z, the potential difference is same as our new source of EMF. Okay, if their potential difference, their voltage is the same, then potential difference will be 0 lah, no difference. Okay, Wesley, no, Wesley. Both answers are wrong. Try again. Chonghan correct. Good job. Chonghan correct. Okay. The rest of you, can you try? I give you some hints. Okay, this part and here the voltage will be the same when the galvanometer is 0. Okay, Chonghan, you no need to wait for us. You can complete others' question. Okay. Then, which change to the circuit allows a much more precise value, okay, for the EMF of the new source to be obtained? Okay, because the 8 milliwatt is so small, okay? Then after that, how you are going to modify the circuit so that even 8 milliwatt, we also can determine it. Very sensitive to know. Wesley, correct. How about others? Manjo, Sean? Okay, Fawal, no. Fatima, yes, very good. Okay, here, any others? Kai Qian, no. Okay, dear, here, we need to eliminate what answer? C or D is confirmed wrong. C or D, they connected in series with the new source. Actually, it doesn't helping, no effect for this. We need to consider about how we make this part, which is my voltage across X, Z. We want to decrease it. Make it very small. For example, this one 8 milliwatt 8 milliwatt. So I need to think about, for example, this part become 10 milliwatt. I want to make it become 10 milliwatt. So 10, maybe we can like divide it into half. This one divided into half. Then this one 1, 2, 3, 4. 1, 2, 3, 4. Something like that. So when you are getting 8 milli, you will become to here. Slightly change, you also can detect. So your task is, because this part is so small voltage, okay, the voltage so small. If you want to make a slightly change, we also can detect, which means that this one voltage, you cannot too high the voltage, okay, for this part, X and Y. We need to this part smaller as we can, okay, as smaller as we can, so that even you see here 10 milliwatt. So let's say we put at here, you get 5, 6, 7, 8. Comes to here, then you can detect, hey, it comes to 0. So it's very sensitive. Even a small voltage for the new cell at here is very small. So at here, we need to make this part smaller voltage. Then how can we make this smaller voltage? We can at here put a fixed resistor to get the rest of the voltage, the largest voltage. So this one is 2 volt. Okay, 2 volt, 2 volt, 2 volt minus the 10 milli. Okay, so 1.99. I need something at here to get the 1.99 volt. Get most of the voltage. Okay, get most of the voltage. This value is I just simply put only. I didn't really count. I just want to tell you the idea. Okay, we make this part voltage as small as possible. So how can we make this? We need to make a resistor outside here to get most of the voltage. So at here, the answer should be B. Okay, to be B. So if let's say here I become 2 millivolt, can we detect? Yes, move to here. Easily to detect a small voltage change. Okay. Okay, for this question, is there any question? Okay, this one more precise. Okay, maybe you can take some note. Okay, we need to make the balance point should able to move a larger distance for a small change in EMF. How we say precise is even a very small change in EMF, we still can move it. We can see the difference. We can move the slider with a distance. We can observe it. Okay. So at here, how are we going to do this? Decrease the potential difference per unit length. Okay, so how next we can decrease the current. Okay, we also can decrease the current. Yeah, decrease the current through the wire. Okay, any question for this? Any question for this? No, Okay, warm up, warm up. Next question, acting, we warm up. This question should be fine. You should be able to answer for the question acting. Can you try? Assume that we warm up using this question to warm up. So try. A cell with a constant EMF is connected across a fixed resistor. Over the time, internal resistance of the cell increase. Which change occurs as the internal resistance of the cell increase? In equation that related with internal resistance, once they're mentioning of internal resistance, there is only one. Okay, so you just think about what happening, use the equation help you, okay, to get the idea what happening. So question number 18, any of you? Zhonghan correct. Sean, no. Sean, think again. Any others? E equals to V plus IR. Okay, so this one unchanged. It's constant. Okay, this one is constant. So they told you that your R at here is increased. R increase, that means that your total resistance also increase. Total resistance increase, what happened to your current? Wesley, correct? Kai Chen, correct. Okay, total current will decrease, right? Okay, total current will decrease. So this one, V, voltmeter reading. This is voltmeter reading. The voltmeter reading is V equals to I times R. So this part is decreased. So this one voltmeter reading should be decreased. Okay, the answer for this question should be B. A decrease in potential difference measure across cell. This one is the voltmeter reading. Voltmeter reading that we measure the capital V, the V. Okay, so is that clear? Is it okay? Okay, good job. Okay, dear. Actually, we goes to question number 23. We did this question before. It's a very tough question. If right now asking you to do one more time, do you able to solve it? That is my question. Do you want to try? Try one more time. Okay, try one more time. Can you, if you able to solve this question, then that means that you learn something already very good lah. Okay, but this question is quite tough lah. We try one more time, although we learned this before. Okay, resistance R change to 3R. This one is the outside resistance. Oh, variable resistance. Okay, can you try? For those don't know, look at my screen. I give some hints. After that, I guide you. X-axis is, let me have a look. X-axis is potential difference across variable resistor. Okay, x-axis is potential difference across variable resistor, which is the capital V lah. Y-axis is the potential difference across internal resistance, small r. V plus equals to IR. Okay, I can give some hints until here. So can you try? In terms of E, okay, the potential difference in terms of E. No current, so you have to trying to think how you make the current disappear, but with the E inside. Chonghan, yes, Chonghan, very good. For a while, yes. I think when we solve this question, Chonghan is not with us, right, Chonghan? Or you are already joined our class? Ah, you have done this question before. Good job. So right now you do one more time and you can solve. That is the thing. Okay, so at here, this one is A over 2 also. Okay, for those cannot solve, we recall one more time how we solve. As long as involved with internal resistor, we write the formula out, okay? So they say that the variable resistor is R, so this is R, okay? To 3R, so later on we got one more case, we have to think about the 3R, okay? So you just put the capital letter R, replace with the small r. Wesley, correct? Then we will get the current. We rearrange the current. Why, teacher, you need to rearrange the current? It's because, can you see that A, B, C, D, there is in terms of E, no in terms of I. But here got R is because later on we can cancel out at here. Okay, x-axis is the potential difference across variable resistor. So this one V equals to I times capital letter R, which is the variable resistor. So in this case, it is small r. So we can cancel the small r at here. Cancel, so we get E over 2. We find the y-axis, which is the internal resistance. We found out that this one, cancel, we also get E over 2. So the starting point must be 0.5 E, 0.5 E. So this one, four of ABCD option, they all fulfill. Okay. Then the problem is, where is our when R become 3R? So what is the graph showing? Okay, so you do the same thing. So here E equals to R is 3R plus R. So which means that it will become 4R. 4RI. Then this one is E. I is equals to E divided by 4R. So for your x-axis, okay, so at here, V equals to I times R. So E over 4R times, now is 3R. Now the case is 3R. So we will get 3 over 4R. Okay, 3 over 4E, which is our 0.75E. Okay, then our y-axis, V equals to I times small r. So at here, this one is E over 4R. So this one is still small r, 1R. Okay, the internal resistance is small r. So after that, we get 0.25E. Your answer for this question should be A. Your answer for this question should be A. Kai Qian A, correct. Okay, dear, we goes to question number 25. This one also easy. Can you try? I just want to make sure your idea is correct. Question 25. Any of you? Hong Han, correct. How about others? Sean, Fatima, Wesley, Kai Tian, Manjo, Jahan. Okay, Fawang. Okay, any of you? Fawang. Yes, Fawang, correct. Any others? Okay, here, many way to solve lah, okay? So we need to find the voltage. Sean, correct. We need to find the voltage. Okay, we can, let's say I found this voltage, voltage across the 3 ohm. Voltage across 3 ohm is 3 over 3 plus 9 times 4. Okay, so at here, I will get 1 volt. That means that at here, 1 volt. So you see, it turned like this. So here 1 volt, that means that here leftover will be 3 volt for this 9.0 ohm. Okay, I go through the 3 ohm, then I will drop 1 volt voltage. Okay, when we pass through the 3 ohm, we will drop 1 volt. So how many volt you remaining? So you get 3 volt left over. This 3 volt actually is provided to the 9.0 ohm. Okay, then the question said that the galvanometer is 0. So at here means that the voltage will be the same. Therefore, no current flowing through the galvanometer. So here is 3 ohm. That means that this part also 3 volt. How it turns? It turns like this. So that means that the 3 volt also given to the 6.0 volt. So the 1 volt will be given to the unknown R. You get what I mean? How it turn also important. From positive, it turn like this. So it will drop 1 volt first, left over 3 volt for the 9.0 ohm. Okay, so I know this one is 3 volt. So this point also 3 volt is because the ammeter, voltmeter, galvanometer here is 0. Okay, so this one is positive, move in this way. Here is 3 volt, meaning that this unknown R is already dropped 1 volt. Wesley, correct. So based on this, you can using the potential divider to find the answer. Okay, let me check. 开千 correct. Okay, so at here I can using R divided by R plus 6 times 9 equals to 6. Okay, equals to 6. Wait, let me have a look. 6 what? Oh, 3 what? Dear, sorry. Here is 9 minus 3. Here is 6 what? Okay, it's equals to 6. So you blah, 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 blah. Your R should be 12 ohm. Answer is C. Very good. Okay, boys and girls, we goes to the question number 33. Goes to question number 33. This whole set, after that you complete by yourself. Then if you're facing any problem, you WhatsApp me. I will show you the working set. Okay. So question number 33. Can you try? Whilst I need to find my battery for my mouse. So you try first, Wow. Wesley, no. Wesley, think again. Sean, no. Wait. Wesley, wait. Let me have a look. Wesley, no. Try. Sean also no. Chonghan, no. Is my problems? Wait, let me have a look. But my mouse is not working right now. Let me change. Guys, try again, maybe it's my problem. Let me check the answer. Let me find out the answer. Maybe it's my problem. But I don't know why my mouse suddenly doesn't work. Mm. Wait ah. How come my mouse is not working? Okay. Okay, dear. Let me have a look. Sean correct. Right now correct. Fatima correct. Fatima correct. Okay, boys and girls, for this question, a cell of EMF by internal resistance is connected to a fixed resistor R. Okay. What? But okay, then what? A voltmeter measure the potential difference between the terminal of the cell. Okay, which statement explain the change to the reading of voltmeter as the contact Z is moved towards the end of the towards NX. Okay, it moved towards at here. Okay, so answer for this question is C. Answer for this question is C. Voltmeter reading increase because the current through the cell decrease. Okay, here V equals to E plus IR. Let me have a look. So at here, move towards to the X. Okay, dear, you see, if you move towards to the X, your circuit will become like this. Initially, if like this, you are something like you sharing part of it with another parallel R at here. Okay, this is initial setup like this. Initial setup. After that, if you move towards to the X, it will become like this. Okay, am I right? It will become like this. But actually, if like this, you won't be passing through the R. It won't be passing through to the R at here. You look at here, this one important knowledge is here. It will just having a short circuit at here, this part. Okay, this part, it will become short circuit. Short circuit for this part. That means that there is no resistance at here. The current won't be choose this path. So we can just ignore, the current won't be choose the resistance R. Okay, it will just goes to the path without any resistance. So if you compare these two, starting initial and then this one is after we move towards to the X, you will find out that at here your resistance become higher. Okay, your total resistance become higher because we don't have any parallel to share out to decrease out the resistance. Okay, if the parallel circuit got the properties that they will reduce the resistance, but right now if we move the slider to the X, that means that we lost this function of parallel circuit to reduce the overall resistance. So when you move in this way, you are increasing your resistance, your current will decrease. Therefore, current will decrease either A or B, C. Okay, then voltmeter reading. Here, V E equals to V plus IR. So this part you decrease. Okay, that means that this part, the voltage that you lost due to the internal resistance will be decreased. So your V at here, this part will be increased. So answer C. I think this question is good idea. Because of this part, the testing on you, do you understand about this? With moving the slider to be X at here, actually your total resistance increase. Because if there is a parallel, it will reduce the total resistance. Okay, boys and girls, do you get the idea about this? The rest of the part actually is same as what previous question we did, just this part. Okay, let me have a look, Wesley. Why is it a short circuit? Because when there is no resistance at all for this part, okay, when you move your slider to be here, that means that this part, it will become like this. here, connected to here. So this is no resistance at all. We call it as short circuit is because current will all the time going to this path without choosing the resistance path, without choosing any resistance at here. So because here nothing, no resistance at all the current just going here. So this is called short circuit for this part, short circuit. If at here you put a very, very small resistance, then we cannot call it as short circuit. Any a small resistance at here, it will do like normal case. Okay, only short circuit when exactly no resistance here. So Wesley, is it okay? This part is short circuit because there is no resistance at all the current will move to here. Okay, this question is good. Okay, so is it okay? Can we proceed to next question, dear? Okay, good job. So dear, we goes to the question 39. Try with question 39. Try. This question easy also, but try. For a while, no. Try again. Oh, different question. Okay. 39, 39, dear. Chonghan, yes, good job. You are very good in physics or you are very good in electricity. Dear, here. Any of you able to get the answer? I can redraw the circuit and give you some hints. After I draw the circuit, I think you were able to solve it. Like this, you should be able to solve. Wesley, yes. Sean, yes. Dear, you must understand for which resistance they are in series, which resistance is in parallel way. So you need to think, you're using your finger, move until here. They got 2 points to split. So that means that 2 paths to move. That means these two is actually parallel. Then your finger move until here. You can ignore whatever ammeter and voltmeter. They are just an instrument, measuring instrument. So you can just ignore it. Your finger at here move. So these two, 2 ohm and 4 ohm, they are in series. Okay. So this is the point that I want to emphasize. So this is voltmeter reading. This is voltmeter reading. Okay, V out is, so you're using 4 divided by 4 plus 2 times E. Okay, divided by E. That's all. Settle the problem. So 2 over 3. Answer is donkey. Okay, let me check. Fawal, correct. Okay, dear, let me find any other question. Okay, maybe we can try question number 44. Right, dear, we try question number 44. We did this question, similar question before that. Now testing on you. Do you able to solve? Question 44. Okay, let me check. Sean, correct. John Han, correct. Any others? Okay, I already redraw the circuit and show you. So you must need to have the ability how to redraw and interpret the circuit. Okay, so at here, this one, okay, the 3 ohm here and 14.4 actually is in series, and then this one R is in parallel with 14.4. Okay, since they said that reading of the voltmeter is 0, that means that the voltage across the 3 ohm, let's say I label this one as X, here Y. So voltage across X must be equals to voltage across Y. That's why voltmeter reading is 0. Okay, so at here I can count 3 over 3 plus this one, I put an Rx first, okay? Because I later on only solve it. So this part, I set it as Rx first, okay? Then after that, it will be times with the voltage. Okay, we put some E lah, whatever. So this one is 2 over 2 plus 4.8 times E also, total voltage. So I label this as E. Why doesn't matter? It's because E and E later on we can cancel out, okay? So if you solve the question, blah, 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 your Rx should be 7.2 ohm. But not yet finished. That is not our answer yet because this is Rx. So Rx actually is the parallel of 1 over R plus 1 over 14.4 inverse it. So this one 7.2. At the end, solve it by using a mathematic way. You should be able to get your R is 14.4 ohm. Answer is donkey. Okay, answer is donkey. So the main idea is this. This kind of question come out a few times within these 5 years. This is a 5 years past year paper, 2018 to 2022. I think so. Okay, yeah. 5 years. It come out for 2 times. So this one we must know how to solve it. Okay, is that clear? Any of you, any question want to ask me? No, so we goes to question 45. Try with question number 45. Try with question number 45. Yes, Chonghan, correct. Fawal, no. Fawal, try again. Any others? Try again. Let me know your answer. Fatima, no. You same answer as Fawal. Sean, correct. Sean, correct. Later on, Fatima and Fawal tell me why your answer is C, but C is not correct. I want to know what is your idea. So then next time I can more understand which part you will make mistake. Wesley, no. Wesley, no. Okay, dear. Here, they say that 4 identical resistance. That means they are the same. So I put R, 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 and R. Okay. So at here, what is the difference between X and Y? So X and Y here in between total is 2R. Am I right? Then this part in parallel way. I did teaching you about the shortcut path, right? When they are same resistance and connected in parallel way, we will just make it divided by how many of them? 2. So resistance divided by 2. Okay, so if I rearrange the circuit like this, ta 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 ta. Okay, here I got R, R, and then here a new R. I rearrange my circuit. So this is R over 2. So here is R plus R, okay? So the potential, the voltmeter reading is actually put at here, V put at here. Okay, like this, actually you can solve the question already. I rearrange the circuit for you. So what is your voltage across X, Y? Here is X, here is X, here is Y. So it will be 2R divided by total resistance, which is 2R plus R over 2. Am I right? Okay, times 30. Times 30. So you have to rearrange. You have to rearrange. Then after that, your answer should be donkey. Or another way, we can calculate the total current first. Okay, V equals to I times R. So total is 30 equals to I times R is 2R plus R over 2. Okay, so blah blah blah, your I should be 12 over R. Total current first. Okay, total current first also can. Then voltage across X and Y. Vxy equals to I times your Rxy. So 12 over R times 2R. So at here 24 volt. You will get 24 volt. Did you get the idea? You need to have the ability to interpret and move the circuit until the circuit that is you familiar lah. Okay, until here, is that clear? Is it okay? Okay, so here, let me choose some question. Okay, can we go to the question number 51? Goes to page question number 51. Can you try? Only 4 steps. Two working steps. You can find the answer. Wesley need to repeat for. Sorry, Wesley. Is it this question, Wesley? Wesley, yeah. Okay, Wesley, you see, they want to find this voltage, okay? So at here, they say 4 identical resistance. So I just put R, 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 and R. Okay, I want to know this voltage, but I also need to settle for this part. To be more easier, I will make them become a single resistor. This one, resistant and resistant, they are connected in parallel. So we can using our shortcut method to find the single resistor, which is using the R divided by, we got total 2, so divided by 2. Then I rearrange the circuit. When I rearrange the circuit, actually everything will be much more easier. Okay, you see, it will be easier. So we want to find this voltage, V equals to IR. Therefore, I find the I first. How can I know the I? I using V total equals to I total times R total. What is my E total, V total, which is my battery 30 volt, equals to the current flowing through the circuit. Total resistance is, because now they are connected in series, so it will be R plus R over 2. So you're using a mathematics. I is 12 over R. So I will find the whole circuit current flowing through the whole circuit, which is 12 over R. Then I want to find this part, the voltage for X and Y. So V equals to IR. Because this is in series, the total current is equals to the current flowing through the R and R. So this one current is the same. So what is the resistance between X and Y? I got 2R here. So after that, I will get 24 volt. Is it okay? Okay, good job. So just now we goes to 51. Let me have a look. Chonghan, yes. Chonghan, yes. A cell of more electromotive force E and internal resistance. See internal resistance. So we always with the formula E equals to V plus IR. Okay. A maximum power can be dissipated by the resistor without heating. Okay, so there is a maximum P. So what is the maximum E? So you have to relate P and E together. Okay, so you have to relate. You see your answer in terms of E. What is your E? Your answer A, B, C, D, or we have the P at here. That means that you have to think how to relate the P inside this formula. How you move the P into the formula. Then can you observe at here? You see, sometimes we don't have idea. Then you have to think. From here, V plus IR. This one P, we got the R, we got the small r. Then where is my I? Where is my I? If I rearrange my question, this question, you see, I also can be I times R plus R. This one is another E. Actually, it's the same thing, okay? Don't confuse. So can you see that I got the capital letter R and small r? So this one, capital letter R and small r. But the problem is I cannot find any I in my A, B, C, D option. So your idea must be think, how can I use my I, replace my I with something with P, okay? I in terms of P. So you have to think what formula related with I. So at here, P equals, we got three formula. Power correct, three formula. I square R, right? So another one is P equals to VI. But option A, B, C, D doesn't have V. So we don't need to using that. We're using the one P equals to IR. 海谦 correct. So your I at here, it will be getting P over R like this. So we put P over R, then R plus R. Okay? So here, then you solve it. Actually, you will get the answer donkey. Boys and girls, this one is I teach you how to think and solve the question. Okay? Sometimes we don't have idea how to change, how to move. Then you look at your option A, B, C, D. Wesley, correct. You look at A, B, C, D. They will involve with P. So you need to think how to move the formula of P inside the E. Then after that, you observe what is missing from the option A, B, C, D. So as here, we found out that current is missing. Current is no longer appears in the A, B, C, D option. So you have to think how you make current, okay? Substitute with the equation with the power inside current, without current, okay? So I must be equal to something, inside something that is a power. That is the idea how we solve the problems, okay? So next, let us choose. Let me have a look. Question number, can you try question number 64? 64. Question number 64. I just go through the rest of the question should be okay lah for you to solve 64. We goes to 64. Try. Actually also easy. Just some concept inside. Do you understand? Do you familiar with the concept only? Chonghan, yes. Very good. Very good. Fawal, no. Fawal, try again. Fatima, no. Fatima, try again. The most important is, do you have some sense? Actually, we need some sense at here. You see, this is 6 ohm. Here is 12 ohm. How the 3 ampere will be shared out, split out. That is the sense in physics. So 6 ohm will get more or less. If more or less, how much it will get? Papa, no, try again. My first question is, what is the current flowing through the 6 ohm? What is the current flowing through the 12 ohm? That is the thing that you have to solve first. Voltage for 12 ohm must be equals to the voltage of 6 ohm. Am I right? Because they are parallel. So the current for 12 ohm times the 12 equals to the current for 6 ohm times the 6. Okay, they must be the same. Then your I for 12 plus I for 6 equals to 3 ampere. Equals to 3. So from here, do you able to find out what is your current flowing through the 12 ohm? What is current flowing through from 6 ohm? Fatima, correct. Okay, so let's say I label this one is I1, this is I2. So I1 plus I2 actually is 3. So your I1 is actually 3 minus I2. Okay, so equation 1, equation 2. Substitute in. So 3 minus I2 times 12 equals to 6I2. That's 8 minus 12I2 equals to 6I2. So at here, okay, so your I2 should be 2 ampere. So this one I2 is 6 ohm, is 2 ampere. Then your I1, 3 minus 2, so it's 1 ampere. Here 1 ampere. Okay, if you got the sense of physics, very strong sense of physics, actually you can straightly know 6 ohm is half of 12 ohm. So that means that the current should be double of the 12 ohm. Double of the 12 ohm. B, you didn't see the power. Oh, okay, power. So boys and girls, this one is to show you very clear where I get the 1 ampere for 12 ohm, 2 ampere for 6 ohm. But if you got a very strong sense of physics, you no need to do this calculation. You can also know that 6 ohm is half resistance of this 12 ohm. So the current should be double of the 12 ohm. So here is 1 ampere, here will be 2 ampere. Add it up together is 3 ampere. Okay, then at here, power dissipated. So at here, power dissipated for 6 ohm. 6 ohm, where is 6 ohm? Here, this part. This part. So at here, I square R. I square R divided by I square R. Okay, this one is 6 ohm, 6 ohm, 2 ohm, 2 ohm. So 6 ohm is 2 ampere, 2 square times the 6 ohm. So it's still 6 divided by current flowing to 2 ohm. 2 ohm. Oh, 2 ohm at here is 3 ampere, dear. So 3 square times 2. Your answer should be 4 over 3. Answer should be B. Okay, here, this question, my main idea is wants you to know about this part. Sense of the physics. 6 ohm is half of 12 ohm. So the current flowing through the 6 ohm should be double of the 12 ohm. Okay, if you want to do calculation, here is the calculation to prove you where I get the 2 ampere and 1 ampere. And then read the question carefully, which part they are asking right now. 6 ohm and 2 ohm. 6 ohm and 2 ohm. So 6 ohm is here. Okay, then 2 ohm. 2 ohm is here. So they have different position having different current. Okay, so this is the answer. Okay, can you try with the question 65? This question, any question? 64, any question? Do you want to ask me any question? No, So we can go to 65. Can you try? Two cells with electron multiforce E1 and E2 and internal resistance R1 and R2 are connected to a resistor R. The terminal potential difference across cell 1 is 0. Which expression about the R? Okay, try. You have to understand terminal potential difference across cell 1 is 0. Yeah, that is the part that we need to solve. Chonghan, no. Kai-Chen, yes. Kai-Chen, yes. Chonghan, yes, correct. Chonghan, correct right now. How about others? Using the way that I teach you just now. Okay, you look at me. We solve the whole circuit first. So the whole circuit, we got E1 plus E2. Okay, this 2 is the provider. Okay, then it will equals to the drop we provide, okay, out. Fatima, correct? So here we will get I times capital letter R plus I times R1 plus I times R2. Because the whole circuit is in series, so current will be the same, okay? So at here, I can take it out all the I also, R plus R1 plus R2, okay? So this one is E1 plus E2. Okay, boys and girls, you look at here. In this A, B, C, D, like what I told you, what is missing and what is we add it up, add it in, something like this, okay? So look at here. We got the E2, E1, we got the small r, we got the E, okay? So we got the E, we got the small r. They're asking you in terms of resistance, what expression can be express the resistance R. That means that R equals to something. But can you see that? What is missing here? Current is missing. From the option A, B, C, D, there is no current here. No current. Am I right? No current. So no current at here. What should we do? You have to solve the current first. Current in terms of your R, okay, or small r or whatever E. So at here, how to solve? This is the important sentence. The terminal potential difference across cell 1 is 0. That means that if you put a voltmeter at here, you will find out that it's 0. What does it mean? Your E1 voltage will be exactly provided to the R1. The voltage drop in resistance R1. Okay, that means that here your terminal potential difference of a cell. Okay, how we calculate the terminal? We will using your E1 minus the voltage that we drop IR, right? So they tell you that the terminal potential difference across cell 1 is 0. That means that E1 minus IR equals to 0. Okay, so what is your I? Why I need to find I? Because just now from here, I know that there is no I in my option A, B, C, D. Then I must replace something into the I. Take it out the I, so replace something in, okay? So it will I equals to the E1 over the small r1. Okay, R1. So at here, we substitute this into here, E1 over R1 equals to E1 plus E2, R plus R1 plus R2. So E1 R1 plus E2 R2 equals to E1 R, then plus E1 R plus R1 plus R2. Okay, then after that, let me have a look. Okay, we divided both divided by E1. So here become R1 plus E2 R2 divided by E1 equals to R plus R1 plus R2. I want to take out the R, okay? So your R should be R1 and small R1 here cancel. Okay, so it will be E2 R2 divided by E1 minus R2. Okay, so at here E2 R1 minus E1 R2 divided by E. Answer should be 8. Okay, dear, is that clear? I want you have the ideal. Okay, you get the total first. After that, you look at the option A, B, C, D. What variable doesn't appear into your option? So you look at it, what you have. So you need to think how you make I disappear, substitute it with the, in terms of, okay, replace it in terms of the E and small r. So this is the answer A. Is that clear? You need to have this idea to solve the question. Is that clear for this, dear? Okay. Okay. Then we go to the question number 70. We try 70. Chonghan. Let me have a look. Chonghan, no. Sean, yes. Sean, can you try to explain to me what is your idea? I want to see your idea. The rest of you try again. Sean, can you give me your idea? Current for both travel through the lamp 2. So lamp 2 is double brightness. Current of lamp 1 only travel through current of lamp 1 only travel through lamp 1 and lamp 3. So normal brightness. Okay, try dear. Okay, boys and girls, the answer should be C. Sean answer is correct. Okay. Okay, boys and girls, we look at here. This one is normal brightness. So what happened? They connected in this way. So which one will be normal brightness? Normal brightness, that means that they will receive the same current as the single lamp at here. Okay. Well, let me check Fatima answer C. Fatima. Fava also answer C. Wesley C. Dear C. Okay, if let's say at here, this one is 1 ampere flow through the circuit. Let's say this is 1 ampere or 2 ampere. Okay, so if here this one, same brightness, normal brightness, that means that the lamp will also receive 2 ampere. Let's say this is 2 ampere. Okay, let's say this is 2 ampere. So that means that 1, 2, 3. Which one after we connect in this way is still 2 ampere. It's still 2 ampere. So at here, this one, you see, this one is one cell. This is one cell. Okay, when the circuit flowing in this direction, that means that the lamp one and here this one actually is like going up. So this one is for this part actually there is not I anymore. Let's say I say this is I. Okay, this is I. So this is same cell. So this is I also. Okay, I also. When I come up to this part, this is I also. Okay, I also. Then this one maybe going down. So somewhere here is no longer I. Because at here I coming, so this one like this. So this part is not I. It's a combination of both I at here. Okay. Then for this one 3, it turns in this way. When it comes to here, this one is I again. Okay, it is I again. Then this one, it will turn like this. Here is I again. Okay, can you see that? But just now, Sean, you got one idea. I want to correct at here. Your answer 1 and 3 is correct. You see, this one, 1 and 3 both receive I. Both receive I. So C is here is correct. C. Okay, lamp 1 and lamp 3 both having the I flowing through it. But at here, this part and this part, actually there is how we say, it is a zero potential difference. Okay, for this part is zero potential difference. So there is no current flowing through at here. Okay, so this one coming back, coming back confirm is I also. Because this one go out and this one coming back, it should be the same I. It should be the same I. So here is I going out, come back here also I. So if here is I, here go out is I, what does it mean? There is no current at here. Dear, this one is very important concept. I repeat one more time, dear. Listen to me. Okay, I erase. Okay, now I want to emphasize at here is, you see, when the current going out, I say this is I. Okay, when it go out and when it come back, it must be the same, equal. So this part must be I also. Get it? Okay, here, second cell at here, it go out with I. It come back also I. Therefore, here is I. You get what I mean? Okay, so can you see that this one is I go out, comes to this junction, and then this I go out. I go into the junction and go out to the junction, still I. What does it mean? Any current flowing through this? My answer is no. There is no current flowing through this. You get what I mean? Because we follow Kirchhoff's first law. Kirchhoff's first law said that total current flow into the enter the junction equals to the total current flow out to the junction. So if here is I, here come back also I, there is no current for this. Lamp 2 actually not light up. So just now, Sean, did you get this idea? Because your statement said that lamp 2 double brightness actually is no light up at all. Chonghan, so it will never have current flowing through the lamp 2. No, yes. Because of this, Kirchhoff's first law. Current flow in and out must be the same. So here is I, come back must be I also. So here I, so here also I. So you see enter and out is the same, so that means no current at here. This is the idea. So answer should be C. Lamp 1 and lamp 3 having same currents of I. Okay? Then at here we goes to question number 72. Is it okay? Question number 72. Okay, let's go. Okay, can you guys try? Wow, so many resistance and then didn't label. So what should we do? Actually, it's the same thing. Okay, try. But then they want you V1. V1 is 8 volt. Okay, so I label here 8 volt. V2 is here 1.0 volt. What is the reading for others? Can you try? This question should be easy. I only got one working step. I only got one working step. You should be able to solve it very fast. No? Wesley, no. Try again. Try again. If you feel the circuit very complicated, dear, you guys can rearrange the circuit without the voltmeter. Hmm. If you rearrange the circuit, will it be easy? Sean, correct. Chonghan, correct. Take out the voltmeter because voltmeter is just a measuring what instrument. Okay, I want to say measuring cylinder, measuring instrument. Okay, dear. You see, here is 1 volt. All resistors are identical. If this resistor I get 1 volt, that means that this one also get 1 volt. So parallel to it, the voltage should be the same. So this voltage should be 2 volt. Okay, from here to here is 2 volt. That means that your upper part should be 2 volt. So voltage 4 should be 2 volt. Then how I know V3? Here you see, total is 8 volt. 8 volt minus 6 volt. How many volt? You get 6 volt. Sorry, 8 volt minus 2 volt, you get 6 volt. So 6 volt at here is for 2 of the resistor. Wesley, correct? So this one should be 3 volt and 3 volt. So you see, 3 plus 3 plus 2, you get 8 volt. So first, you minus first. 8 minus the 2 volt. So you get 6. 6 will be shared by these 2 resistors. So it's 3 volt and 3 volt. Answer should be B. Okay, let me have a look. Next question. Let me have a look at here. Okay, question number 83. Can we go to question number 83? Can you explain how V4 is 2 volt? V4. Okay, dear, you see, the rest of you can try 83. Okay, dear Fatima, you see, this is 1 volt. Because this resistor and this is also resistor, they are similar. So that means that here I receive 1 volt. This one must be also 1 volt. In total, for this point to this point, it receives 2 volt. Then can you see that these two actually is parallel? Here I get total 2 volt. That means that the upper part here, I also get 2 volt. Okay, yes. So boys and girls, we go to question number 83. Okay, try. Actually, in your AS, they like to asking this kind of question. So you need to rearrange the formula and then find out what is the shape of the pattern based on the equation. So you need to know your mathematics very well about the graph. For example, x squared. So how the graph showing, okay? 1 over what? 1 over x, 1 over x squared. Okay, can you try? Yes, Chonghan, but which one? Wesley, no. Almost there, dear. Fawa, correct. Fawa, yeah, good job. Yes, correct. Chonghan, yes, correct. Chonghan, correct. Okay, deal. You see, oh, there is an internal resistance. So we use the formula E equals to IR plus I times R. Okay, because here we involve with I. Therefore, I changed the V become I times R. Okay, so at here, I want to know how about your I. So I rearrange E divided by R plus R. Am I right? So at here, E and R is fixed. Fixed doesn't change, able to change. Okay, fixed. So your small r at here is your internal resistance. You are going to change the internal resistance from 0 until certain amount. So you are changing the small r. So I will be directly proportional to 1 over r. Am I right? in your mathematics, y equals to 1 over x. How was your shape? Your shape will be curved like this. Am I right? So your answer only A or B. C and D is wrong because this is your mathematic graph. Y equals to your 1 over x. It will be a curved graph. Okay, until here, is that clear? So right now, until this step, it's only A or B, only A or B. C and D, no need to think, okay? But teacher, which one, A or B? So easy. What is the difference? The difference is this part at the front, whether it touching to the axis or not. So you look at here, when the R at here is 0, we want to know that whether it's touching or not. So at here, E equals to V plus IR plus I times R. So when R is 0, we want to know is there any reading. So E will equals to I times R, right? Because here this one becomes 0. So E equals to IR. So E equals to IR, what does it mean? It touching, okay? EI will equals to E over R. It got a value. So it should be touched. It should be touched. And then if touching, this value should be E over R. Answer should be B. It will touch. Answer is B. Is that clear? Yes or no, dear? Question 87 is a good question. We goes to question number 87. Go to question 87. Here, this is a good question. Like, dear, try. Chonghan, you already get the answer, is it? This is your answer? 87? Or this is the previous answer? Still doing okay, okay. Last chapter is very easy. After finish the last chapter, we can proceed with the past year questions. Okay. So I think topical questions is very good because you keep on practicing the idea and the concept. Chonghan, yes, correct. The rest of you, I'll give you some idea. Resistance between Y and Z is found 2.5. Y and Z. So that means that maybe this part, okay, we can having the circuit something like this. Whatever, I just draw like this. Y to Z. So if I draw the circuit, it will be like this. Okay, this one will be 5 ohm. Here will be R and R. You must agree with what I draw. You must understand what I draw right now. Okay, so the resistance between Y and Z. So Y and Z is upon. Y and Z is here. Okay, so for this one, we can find the resistance R. We can find what is the resistance R. So between these two, actually we got two paths there. Path 1 and then we got path 2. Okay, path 1 and path 2. So these two, the total resistance for this YZ is equals to 1 over 5 plus 1 over 2R inverse it. This one will equals to your 2.5 because it said that the total resistance between these 2 points. So you have to rearrange the circuit. Okay? At the end, you will get the resistance is 2.5 ohm. So this one is 2.5 ohm. Here is 2.5 ohm. Now, you only can proceed to the question here. What is the resistance between X and Y? So now you have to rearrange the circuit based on X and Y. X and Y will be your point at here. So this is the resistance R. Here is resistance R plus 5.0 ohm. Here is R, here is R. Okay, the R we already get it 2.5. Here also get 2.5 ohm. Okay, so what is the total resistance across the X and Y here? So XY equals to 1 over 2.5 plus 1 over 7.5. Okay, here. 1 over 2.5 plus 1 over 2.5 plus 5. Inverse it. So at here, answer will be 1.9 ohm. Okay. So boys and girls, the idea at here is, do you know how to rearrange the circuit? Now I want to find this point. Okay, X, Y, and Z, Y and Z. So you have to rearrange your circuit to become like this. So this one, Y to Z, here is one path, path 1, and then this is path 2. So boys and girls, for this step, is it okay? Do you get what I mean? Y and Z. So this is path 1. Then this is path 2. From here, you can solve and find your R. After that, what the question want? X and Y. So these 2 points. Okay, so this one is path 1. Here is path 2. So for this question, is that clear? For this question, is that clear, dear? Yes. How about others? Sean, Wesley, Kai Tian, is it okay? Okay, good job. Okay, dear, goes to question number 89. 89, we did similar question before. So this one also needs some sense. If you got the sense, then you can solve it very fast. Okay, so you try 1.5 ampere. Enter the junction X and leave the junction Y. Many way to solve, many way to solve. Chonghan, yes, correct, Chonghan. Chonghan, do you mind to share with me how you solve? Actually, many way to solve. I want to know which one actually your idea will be. Your idea is there. How you solve it. The rest of you solve it and then tell me your answer. Chonghan, you tell me whether you like calculate the total resistance first, then find what? Or you find the current. What is your idea in solving this? Kai Qian, correct. You find total current first. Total current is 1.5 what? Oh, you means that you find the current that split out or what? Total current is 1.5 what? I then find the resistance of each branch. Okay. That means that you get 70 and 140. Oh, am I right? Then? Okay, then. The rest of you, Sean, Wesley? Power. Yes, power, correct. B. Okay, dear. If I using the sense of physics, you try to understand from this. Later on, I do step by step. Okay, but now I tell you the sense. Okay, this is 70. So here is one path. Here is 70. Then we got a second path is here. The 50 plus 30 plus 60 is 140. So if I draw my circuit, it will be like this. 70 ohm. Then here is 140 ohm. Okay. Just now I told you, if you have a strong sense of physics, actually the question will be solved easily. You see, 70, 140 ohm is actually 140 ohm is double resistance of 70. So that means that this current, this current is actually half of the current of the 70. That means that this current, current 1, okay, this is current 1, actually is double of current 2. This is current 2. You get what I mean? This one, resistance is half of this. So current will be double of it. Do you agree? I repeat, this one, 70, is a half of resistance of 140 ohm. That means that resistance half of it, current should be double of it. So how many portion? 2 plus 1 is total 3 portion. So this one is 1.5 ampere. This 1.5 ampere you should split into 3 portion. So 3 portion, that means that each portion should be 0.5. So this one should be 0.5 ampere. Current flowing through, here 0.5 ampere, here 0.5 ampere, here also 0.5. Because this path is actually in series. This path actually is in series. So boys and girls, can you see that I never do any mathematics? I know a bit mathematics, but I already can get the answer because of the sense of physics here. 70 ohm is half of the resistance, so my current should be double up. My current is double up, so this one total added up is actually 3 portion, mathematic 3 portion. 1.5, 3 portion is 0.5. So I already get the answer 0.5. You get my idea, dear? Do you able to get my idea? If cannot, then we have to do step by step. If cannot, then we have to do set by set. How can you solve? Actually, you can find the total resistance. Total resistance in parallel is 1 over 70 plus 1 over 140 inverse it. So your total resistance 46.67 ohm. Okay. Total voltage equals to total current times total resistance. Current in total is 1.5 times 46.67. So you will get 70 volt. That means that here, the parallel path, you can get 70 volt. Then after that, I move to here, no space. So V for 70 ohm is actually the current for the 70 ohm, resistance for 70 ohm. Okay, so this one current we don't know, but I know total resistance is 70. The resistance is 70, so the current is 1.0 ampere. The current for the upper part at here is 1.0 ampere. So I'm using Kirchhoff law. So your I2 should be the 1.5 minus 1.0. So I get 0.5 ampere. This is one of the way how we solve it. You get my idea, dear? Do you able to get my idea? Or you can using V equals to 30 ohm. Okay, if you're using V equals to 30 ohm equals to I2 times the resistance. I want to emphasize at here. You see, can I using I2? I want to find I2. Okay. 30 ohm. Can I say that 30 ohm is 70? Then resistance here is 30 ohm. Can I do so? What do you think, dear? Can I do in this way? You see, I want to find this current flowing through 30 ohm. Can I use the method that I write down right now? Do you think that can I? Can you tell me what is my mistake for if I do in this way? This is a common mistake done by student. That's why I want to tell you. Any of you can detect what is the problems here. I want to find the current for 30 ohm. Then voltage for 30 ohm equals to currents 2 times the resistance for 30 ohm. It looks like makes sense, dear. But what is the problem? Chonghan, do you able to tell me why I can't do so? Wesley, supposed to be the total resistance of the branch. Yes. Dear, common mistake students think about 30 ohm, so they want to substitute 30 ohm in the R. But you don't forget, they are in series, so the current is the same. That means that the resistance, you have to consider this total resistance. For this 70 ohm, it's not only for you. Sorry, 70 volt is not only for this 30 ohm. No. Unless you know how much the voltage is dropped at this 30 ohm. But for this 70, actually is for these three resistors together. If like this, then your resistance should be 140. The three resistors added up together become 140. So your I2 at here, you get 0.5 ampere. This is the physics concept, electric circuit concept. A lot of students, they will make mistake at here. Okay, get it? But now you see, my make sense idea about this is much more faster. Am I right? Did you get the idea here? Okay. Now I want to go to question 94. There we go to question 94. Okay, we goes to question 90. So just now the answer is B, 0.50. 94. Chonghan, yes. Oh, Chonghan, very good. Yes. Sean, no. Sean can try again. Chonghan, correct. Very good. Actually, this question similar with just now one of the question that I got mentioned the idea. Kai Chen, correct. Oh, very good. Fawao, no. Fatima, no. Okay, dear, here, let me explain. Okay, this one, as I told you, we can label this one is I1, right? Go out. And then it come back also need to be I1. Okay, this one is I2, go out. So here come back must be I2 also. Okay. Wesley, yes, correct. Okay, dear, here, you look at here. So this one is I1. So here come back, here is I2. Okay, so at here, let me have a look. So this one is come back here. This one going out. I1, I2. Okay. So your I2 at here, it doesn't change. The I2 at here stay the same. Stay the same. Going back and coming back stay the same. Okay. Then here, that means that there is nothing to split up. Okay. Nothing to split up at here. Nothing to split up because this I1, I2, then here also I2 come back. So at here, the things that I want to emphasize is there is I equals to 0. I equals to 0 for the ammeter. Here ammeter reading is 0. I equals to 0. I equals to 0, that means that nothing to split at here. If here like this, that means that this upper part, I also equals to 0. Nothing to split up. Okay? So the I1 come at here, nothing to split out, and then go back. If you got something at here, this one is 0 lah, okay? If you got something at here, you doesn't able to follow, obey the Kirchhoff first law. Okay? So this one, I2 stay the same at here. So if your ammeter here, they told you that ammeter is equals to 0, that means that the bridge for this part. Okay, so at here, this part. Okay, the bridge at here, it should be, I label this one as X, here is Y. It should be 0 also. Okay, I is equals to 0 also. If like this, we only can follow Kirchhoff first law. Okay, into the junction and out of the junction is still the same. Okay, then after that, they're asking you to find your arm. That means that you need to know this. Okay, so since no current, that means the voltage across at here is the same. Okay, so we calculate the voltage for this 50 ohm. Voltage for 50 ohm equals to 50 divided by 50 plus 100 times the 12. So my answer for this one is 4.0 volt. Okay, it will drop 4.0 volt lah. It will drop 4.0 volt for the 50 ohm. Then at here, voltage for the X at here, this one, it will get 4 volt. 12 volt minus 4 volt. So at here, point X, voltage for point X actually is 8 volt. The 8 volt will be given to this 100 ohm. Okay? Okay, then after that, I not equals to 0 here. Okay, then after that, so voltage across the Y at here, Y point at here. So this one, voltage across Y is also 8 volt. Because there is no current, so no potential difference. This one, X is 8 or 8 volt, so here Y should be 8 volt also. 8 volt. Okay, so at here 8 volt. So how you are going to be get 8 volt? That means that your 24 volt, now you left over 8 volt. So your R at here, you will receive 24 minus X, you will receive 16 volt. This part you will get 16 volt. Okay, this part you will get 16 volt. So you can using your mathematics, R divided by R plus 200 times the 24. Actually, you will get 16. So at the end, R is 400 ohm. Okay, I repeat, you must be very clear. If here is I equals to 0, that means this part also I equals to 0. It must be. If not, it doesn't follow and obey the Kirchhoff first law. Okay, then after that, I can find out the voltage for this is 4 volt. So 12 volt minus 4 volt because it dropped. So I know that at this point actually is 8 volt. Okay, 8 volt at here. So 0 current, that means here also 8 volt. 24 volt move in this way, okay, move in this way. So it will drop certain voltage and then left over 8 volt. So you're just using 24 minus 8. So I know that resistance R receive 12 volt. Sorry, 16 volt. So you're using potential divider to find it out the R. Here, the things concept is actually this part. I want to tell you about this part. Okay, is that clear for this? Kai Chen, okay. Fatima, okay. Wesley, okay. Fawa, okay. Good job. Okay, let me think. We choose one or two more questions. Okay, question 99. We do question 99. You goes to question 99. Question 99. Next week we goes to the last chapter. Last chapter very easy. I think even easier than the chapter 1. Sean, is it this is your answer for this question 99 or previous question? Oh, Kai Chen, good job. Yes, correct, Kai Chen. Sean, no. Sean, correct. How come so fast you can change your answer? Oh, you know already. Okay. Mistake. Chonghan, yes, correct. Okay, dear at here, actually this one you can using your mathematic. For me lah, I just using mathematic way to solve. Okay, we know that the 5.0 ohm, it will be balanced by the 12.5 cm. Am I right? Okay, they said that if they put between Q and R at here, this one is 10 ohm. If 10 ohm, what is your length to balance it? Your mathematic ratio 5 times 2 is 10. Then the length also double up lah. So this one should be 25.0 cm. So your answer should be B, C, or D. Okay. Then Q and S. Q to S is 25. Am I right? 25. So this one is in between is 25 ohm. If 25 ohm, so what is your answer? Okay, so you need to times 5 lah. 5 times 5 is 25. So it's 12.5 times 5. Your answer should be 62.5 cm. So 62.5 cm. Only B and D. Okay, then continue P and R. P to R is 15. 15 ohm. 15 ohm. 15 ohm is times 3, so 12.5 times 3. So it's equals to 37.5 cm. So your answer should be B. Is that clear? Okay, we still got 2 minutes, so we do one more question. Question 101. 101. Question 101. Fatima, correct. B. Correct. Using mathematic ratio, solve it, settle. Easy. Okay, goes to 101. Theory. John, correct. How about others? Give me your answer. Chonghan, correct. Okay, boys and girls, here. When the switch is closed, EMF of battery will fall. No, EMF will remain constant. Okay, when we close the switch, the voltmeter reading will drop. The voltmeter reading, actually when switch is closed, the voltmeter is no longer measuring EMF. So you cannot say EMF false. No, EMF is constant, okay? So A and B confirm wrong. So potential difference across battery, when switch is closed, this one is measuring voltmeter. This one actually is the voltmeter reading, which is our V. Okay, the voltage at the external circuit. So E equals to V plus IR. When we close the switch, this one is doesn't fall. It's a constant value. Okay, but the V at here, this reading, this reading is measuring the external circuit. Okay, the voltage across the external circuit, which is our R at here. Okay, if I draw my circuit before we close the switch, okay, before we close the switch, so here like this, like this, like this, like this, okay, then there is a resistance. So we put a voltmeter like this, voltmeter. Okay, the reading show you maybe 3.0 volt. After we close the switch, I still having my voltmeter at here, but I found out that 2.8 volt. Hey, how come? The potential difference across the battery falls. The voltmeter reading here no longer showing 3.0 volt. Why? Because there is internal resistance inside the circuit here, inside the battery. There is internal resistance appears. So this one small r. No longer 3.0 volt for your voltmeter reading. It's because right now your voltmeter reading is measuring the voltmeter outside, volt potential different external circuit. Okay, so your voltmeter reading after you close the switch, it is measuring the voltage at the external circuit. Okay, so why it become 2.8 at here? Why it become 2.8 here? This one become 2.8. Initially this one is 3.0, now become 2.8. Why? Because 0.2 drop due to the internal resistance. So they need to have some work done against the internal resistance. Answer is C. Potential difference across the battery right now actually is the voltage at the external circuit R. Okay, is that clear for this part? EMF doesn't change, still maintain 3.0. Okay, so if there is no questions, then that's all for our lesson today.